Hello, this lesson is about the trig identities. We've been talking about the unit circle and we'll continue discussing the unit circle. One vocabulary word you need to know is phrase is coterminal angles. These are angles that share the same initial and terminal sides. Remember, initial means beginning and terminal means ending. So if we look at the angle, which is in blue, we can see here's our, okay, I don't think it came out. Here's our initial side, and here's our terminal side, our ending side. And we can see that two different angles are written. We have 135, and it begins here and it goes this way in the positive, counterclockwise. We also have this angle, which is negative 225. It begins in the same place as the 135, but it goes clockwise in the end. So these two angles would be considered coterminal. Different angles that share the same initial and terminal sides. And because of it, it also has the same reference angle. Right, so let's look at this. Are these the only two? Can I write other angles that have the same initial and terminal sides as these two? Let's think about it. So if I have 135 here, what if I continue my rotation? I'm going this way. What if I continue and do another rotation? So what if I had 135 plus 360? Right, so it would still have the beginning because it went this way, right? Maybe I'll draw it out like that here. So that would be coterminal. What if I give it another rotation? Another 360. That still has the initial and terminal side. So that's another coterminal. So that's two more positive ones. What about another negative one? Could I have another negative one? Okay. I'm going to draw it on the inside. So what if I did a rotation inside like that? So that would be negative 225 and taking away another 360. And just going more in the clockwise. I found another negative. So all these coterminal angles, they all have the same reference angle here. And because they all have the same reference angle, that means they have the same sine, cosine, tangent, cosecant, secant, and cotangent. All those values would be the same. So that's why coterminal angles, when we do this, we use the reference angles because that's why because it's the same. And then all your trig ratios would be the same. All right, we've already done this. Okay, so let's practice. Write two coterminal angles, one positive, one negative. All right, so first of all, let's draw that one. What quadrant? Well, I believe it's going to be here in the first quadrant. Like that. So let's write another positive one. So I'm going to take it and go around one more. So that's 80 plus 360. That's going to be 440. So that's one positive. All right, for negative, I'm going to go, again, remember we always start here. I'm going to go in the opposite direction, clockwise, and go this way. So that is 360 minus 80. It's going to be negative 280. So we have one positive and one negative. All right, next one. So we can do it in radians, or we can change it to degrees. So this is negative 390. So that is one. Okay, remember we start here. Okay, so that is one full rotation and a little bit more, 30 more, right? So this right here is going to be negative 30, which is the reference angle, but that's also another angle. So that is one negative. So what about a positive? So we're starting here again, and we're going around this way to our terminal side. So that's going to be 360 minus 30, which is 330. So I have one positive and one negative. All right, so we've talked about the unit circle and have condensed it onto one page, talking about some of the properties of the different signs in the different quadrants. Here, the first, the second, the third, and the fourth. So now we need to talk about identities. Identities are true statements in Trig, and they come in different classifications. So these first three identities are called reciprocal identities. Now I've talked about it several times that secant, cosecant, and cotangent, did I say that right? Are reciprocals of sine, cosine, tangent. So in one way to write it is put 1 over sine, 1 over cosine, 1 over tangent, and they're the same. So how is that true? So let's look at 30 degrees. Let's look in our first quadrant. Okay. If this is 1, this is going to be a half, and this is root 3 over 2. So if we see the sine at this angle of 30, we know it is half. We know the cosecant is 2, right? We know that. So let's look at it over here. So the identity says this. Another way to write the cosine of the angle, in particularly, I should have written this as 30, because we're talking about 30. Okay, so for 30 degrees, I could say it's 1 over sine, and the sine is 1 over half. Okay. So clearly not simplified. So what I would do is multiply this by 2. Multiply this by 2. This would go to 1. So it's 2 over 1, and that equals 2. Right? It's true. So for the next one, let's see, cosine of 30, square root of 3 over 2. And when we put up tangent as well, that's going to be the square root of 3 over 3. So for secant, you should know it's 2 root 3 over 2, and cotangent is root 3. So does it hold true for the other ones? So let's take, so secant of 30 equals 1 over cosine, 1 over the square root of 3 over 2. So multiplying 2 again, top bottom. So that equals 2 over root 3. And that rationalized denominator. So is it the same? Yes. So this is just a different way to do what we generally do. So it's an identity. So some people learn this method. I generally still just use my triangles. But later on, so we're going to have 1 over tangent, 1 over root 3 over 3. Now, do you have to use this method? No. Rationalize the denominator. So it's the same. It's just showing that this is a true statement. Right? Now, when I actually have to find a value, I use my right triangles and I don't use this. But later on, we're going to be using these identities for small proofs, for proving. So we're going to need them. All right, another fundamental identity is the quotient identities. And this is saying that tangent of theta equals sine theta over cosine theta. And some people often, I tend to use the quotient identities more than I use the reciprocal ones. Usually for the reciprocal, I usually just flip the numerator and denominator as opposed to 1 over sine or 1 over cosine or 1 over tangent. So these I tend to use often. So tangent is also equal to sine theta over cosine theta. So is this true? Well, let's go check that. Let's use a 60-degree angle this time. First quadrant still. Root 3 over 2 and half. So I know that sine is of 60. Sine. Keep using theta. Is root 3 over 2. Cosine of 60 is half. And tangent is root 3. All right. So for the tangent of 60, I could say this. It's sine over cosine. Sine is root 3 over 2. Okay? And cosine is a half. So if I multiply 2, right, it would be root 3 over 1, which simplifies to root 3. Now, is that the same? The answer is yes. So just another way to do it. So if you already know sine and cosine, so you're given that and you don't want to draw the triangles, you can use this identity. So for cotangent of 60, it's saying the reciprocal, right? Which would make sense. It's tangent and cotangent are reciprocals. So it's half over root 3 over 2. So if I multiply the 2's, I'm going to write underneath it's 1 over root 3, which simplifies to, rationalizes to this, which we do know that would be true for cotangent, right? It's reciprocal of that. All right. The last of our fundamental identities that we're going to talk about in this lesson is the Pythagorean identity. There's 3 Pythagorean identities, but this one is the most important, so I put a double asterisk. It's sine squared theta plus cosine squared theta equals 1. And some of you may have seen this from geometry, so I'm going to prove it to show you how it is true. Oops. Okay, back that way. All right. Now this one I'm going to do different because I don't have a number. I'm just going to use any old right triangle. And it's called a Pythagorean identity, so guess what we get to use? The Pythagorean theorem, yay! So I'm just going to talk about an angle, theta, and I'm going to use A, B, and C, knowing that I'm probably going to use the Pythagorean theorem because it's called the Pythagorean theorem identity. So if I'm looking at this angle, sine theta, if I'm looking at this, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So using substitution, so this is actually the same as this. We just write it like this so not to be confused. So we write the squared here, not to be confused, and it's a little easier since you don't need the parentheses. But they are equivalent. So using substitution, I'm going to put b over c squared. And the cosine is a over c squared equals 1. So I'm going to square it, which is b squared over c squared, which equals a squared over c squared. Common denominator, right? Therefore, I have b squared over a squared equals c squared. Well, what do I know about b squared plus a squared? Well, a squared plus b squared equals c squared by the Pythagorean theorem. So by more substitution, c squared over c squared, which equals 1, which equals 1. Okay, so that's why it's true. Now, from this identity, we can prove more identities, but they come from the Pythagorean theorem, from this original one. So if I take this one, sine squared theta plus cosine squared theta equals 1. What if I just choose to divide each of them, each term, by cosine? Oops, I wrote that wrong. Sorry. So I'm dividing each one by cosine squared. And you're saying, why? Because I can. Okay. Well, what does it equal? Well, guess what? It equals that. Sine squared over cosine squared equals tangent. That is our quotient identity, right? This equals that. Cosine squared theta divided by cosine squared theta is 1. 1 over cosine squared theta, that is secant squared theta. That is from our quotient identities. No, not quotient, sorry, reciprocal identities. So this is our second Pythagorean identity. What if I start from this again? But instead of dividing by cosine, what if I divide by sine? And so I'm going to divide by sine squared. Okay, well, this one I think we're going to do. So sine squared over sine squared is 1. Cosine squared over sine squared, that is cotangent. That is from quotient identity from our last slide. The 1 over sine squared is cosecant squared. So this is our next one. So these are the 3. Sine squared theta plus cosine squared theta equals 1. The other one is tangent squared theta plus 1 equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. Now, note that you can add and subtract things from both sides. So this, I can subtract 1 from both sides, and I can get this. Right? That's true for the other 2 as well. All right, so we're going to use our properties to evaluate the expression. We're not going to use a calculator. All right, so hopefully you have your notes so you can look at it to see your properties. Okay. So I have tangent of 50. Now, this is not a special angle that I know. It's not 30, it's not 45, it's not 60, 90, 270, nothing like that. So I'm going to have to use a property, see if I can figure out the value. So tangent 50, I don't know anything about that. But here I have sine over cosine. Sine over cosine, that's tangent. So this is going to be equivalent and equal to that. Okay. So now that I've rewritten it, I have tangent 15 minus tangent of 15 degrees. That's 0. Nice. Okay. So what about this one? Okay, what do I have? I have a secant and cosecant. Well, what do I know about them? They are reciprocals of each other. So this, I can rewrite it. 1 over cosine 3 pi over 7 times cosine 3 pi over 7. So this is a numerator, that's a denominator. So they both simplify to 1. So my answer for this one is 1. Like it. I like using the properties because it is satisfying at the end. You have something big, you start with something big, and you get something small at the end. All right, so let's look at this one. So let's look at our properties. Now, it has squared. So squared, to me, is a sign of, hey, I may have to use a Pythagorean identity at some point. But I have a fraction here in the first term. So is there a way I can rewrite that? So 1 over cosecant, so its reciprocal then would be sine squared. Okay, so this equals that. So plus cosine squared pi over 8, same angle, the sine and cosine both squared, so that equals, ding, 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 1. So we just have to make sure that the angles are the same. All right, this one's a little bit more complicated looking at it. I don't know. It's not a quotient. It's not a reciprocal, but I have squared. So it's probably Pythagorean theorem identity, so I'm going to look at it. I'm going to look at my book. Hopefully you're looking at your notes, and I can see that I can rewrite this. All right. So I have cotangent squared 49 minus this using the Pythagorean identity. Yes, you have to put the parentheses. That equals cotangent squared theta plus 1. Oop, what's my theta? See, I looked in my book. But my theta is what angle? 49, my bad. So we're going to use 49. Now, the reason why the parentheses was important, it's important because when you change the signs, this 1 becomes negative because you have to distribute it. So cotangent squared 49, that's going to equal 0 minus 1. So the answer is negative 1. So the identities, I said I wrote properties, but it also means the identities as well. They take a little bit of time to get used to. So make sure you're looking at your notes and you have all the identities. It's helpful when they're all on one page. All right, so here are 2 problems for practice on your own. Refer back to the notes or the video for help. Again, when I say properties, this also means identities. All right. Thank you for watching. Ciao.